Hello and welcome to Module 3, Creating Virtual Machines. This is part of the VMware vSphere 6 Install, Configure, and Manage course. Module 3, Creating Virtual Machines. This is the third module in a 12-module series. The importance of this module. You can create a virtual machine in several ways. Choosing the correct method, however, can help save you time and make the deployment process manageable and scalable. Module lessons, there are two. Lesson 1, Virtual Machine Concepts, and Lesson 2, Creating a Virtual Machine. Lesson 1, Virtual Machine Concepts. The learner objectives. By the end of this lesson, you should be able to meet the following objectives. Identify the files that make up a virtual machine. Compare virtual machine hardware version 11 to other versions. Describe the components of a virtual machine. Compare and contrast the types of virtual disk provisioning. And view the console of a virtual machine. About virtual machine files. A virtual machine consists of a set of related files. We can see a whole series of related files here in the blue box. However, they are all contained within the virtual machine folder. This encapsulates that virtual machine. The VM files are stored in the directory in the data store. That VM folder usually contains all the VM files, but this can depend on how the VM is built. Let's take a look at some of these files. The .vmx file, this is the VM configuration file, and this typically includes your device settings, things like the amount of memory, etc. There's also a vmtx file. This is the template file, and you can use this to create a virtual machine and then convert to a template. This can't be powered on, but is used for deployment only. To use, you copy the template or clone to a live virtual machine. When you convert a virtual machine to a template, its .vmx file is converted to a .vmtx file. Another file is the vmdk file. This is the hard disk file. Typically this one is the disk descriptor. You also have the actual data file. And the info that is stored here, if the operating system doesn't recognize SCSI, it can see it as IDE. There's usually more than one vmdk file. We're going to take a look at a couple of these. The vmsd and the vmsn files, these are snapshot files. Now these are used for restoring the virtual machine to a previously saved state. We'll talk more about snapshot files later. There's also a delta.vmdk file. Now this delta file stores changes to the disk since the current or last snapshot. In our labs themselves, these delta files are created, but they can actually be deleted or ignored because when the NetLab spins up and creates that delta vmdk, when you shut it down, then the lab is normalized, meaning that it restarts from the original vmdk file. Therefore, it ignores these delta files. They're only really used with persistence. And the last one I want to mention is the log files. Up to 6 log files can be maintained at once. The oldest log file is rotated out as needed. So if you need to save these, then you're going to need to back them up to some other source or some other location. Let's talk about the virtual machine hardware. A virtual machine uses virtual hardware. In this case, we're looking at up to 128 virtual CPUs. Those CPUs will appear as real hardware to the virtual machines. The uniform hardware that's provided by this functionality makes the virtual machines portable across hosts, meaning they're not dependent upon differences in CPU from one host to a next. Besides the 128 virtual CPUs that are supported per virtual machine, we can support up to 4 terabytes of RAM. Again, this is per virtual machine. Hardware acceleration, 3D hardware, up to 10 virtual NICs, 2 IDE controller devices, 3 parallel ports, 32 serial COM ports, a VMCI controller, an HCI controller, a USB controller for up to 20 devices, a floppy controller, you can control up to 2 devices with that. The SCSI adapters are particularly important because this is where we'll be connecting our VMDKI files. You get up to 4 SCSI adapters, and each of those SCSI adapters can handle 15 devices. So we can see we can connect up to 60 SCSI devices. So you could have 60 virtual disks. Now, going back to your USB devices that we looked at a moment ago, those USB devices, they will attach to a single virtual machine. They cannot be shared amongst the virtual machines or the host. So when you attach that USB device that's actually connected to the host, it then can connect to a virtual guest, but only one at a time. A word about the virtual ports. These are passed through to the ESXi hosts. So if you want a serial port in your virtual machine, you can extend it into the physical host serial port. Also, the VMCI controller, a couple important points about that. This is the virtual machine communication interface. It provides communication between a virtual machine and the ESXi host operating system. This reduces network overhead by bypassing the network layer itself. These are pretty speedy. You can get up to 10 gigabits per second. The VMX Net 3, which we'll be talking about shortly, that network interface is only up to 2 gigabits per second. The VMCI controller can be both connectionless and connection-oriented. Connectionless meaning using something close to a UDP, and connection-oriented something like a TCP. A couple other items here. We can connect to the mouse and to the keyboard so that we can interact with the virtual machine directly through a console, which we'll take a look at a little bit later. Let's move forward and take a look at virtual hardware versions. Now, the virtual hardware version determines the operating system functions that the virtual machine can support. You do not use a version that is higher than that supported by your VMware product. So notice that we're up to hardware version 11. That's for the ESXi 6 and later. ESXi 5.5 and later, you have 10, all the way down to ESXi 6, which is 4.0. I said 6, excuse me, ESXi and ESXi 4. That's hardware version 7. Now, each release of the VMware product has a corresponding virtual machine hardware version included. This is the hardware abstraction layer, or otherwise known as HAL. This is all based on the hypervisor that's in use and your hardware version number. And if you create a virtual machine or an OVA or OVF on ESXi 6, you won't be able to open it on ESXi 5.5, which is version 10. Meaning if you create one in version with version 7 capability, you can't move that virtual machine to an ESXi host at a lower version number. However, if you create a virtual machine on ESXi 6 and give it a lower hardware version, let's say version 10, you could then move that version, that virtual machine to ESXi 5. To a vSphere server with ESXi 5.5 because it does support version 10. So that's something to bear in mind when you're creating virtual machines. Let's take a look at some of the features with that version 11. We've got some new features with 11. With 11, you now have VMX Net 3. Previously, it was at VMX 2. This is a high-performance interface, and this supports, you can see here, large receive offloads, which can result in reduced associated CPU costs by reducing your network packet processing. We'll talk a little bit more about VMX Net 3 later. Some other new features with that. Virtual NUMA Aware Hot Add RAM is now available, and USB 3.0 controller. And you also get extended support for virtual graphics, including the NVIDIA virtual GPU. You also get expanded guest OS support, Solaris 11.2, Ubuntu 12.04, and 14.04.1. FreeBSD 9.3 and Mac OS 10.10, and your VMware tools, which are an add-on to virtual machines. So we're getting better mouse and keyboard support. We're also supporting remote shutdown of your virtual machines using an icon in the vSphere. This shutdown command is then passed on to the operating system, so you get a normal quiescent shutdown. On Linux, you can log in under sudo and then pass the command shutdown-h0. A couple other things to be aware of. Again, we can support up to 128 virtual CPUs, 4 terabytes of RAM. These were on the previous slides. Let's talk a moment about the CPU and memory. So you can add, change, or configure your CPU and memory resources. This will improve your virtual machine performance typically. The maximum number of virtual CPUs that you can assign to a virtual machine will really depend upon the number of logical CPUs on the host, the host operating system license, and the type of installed guest operating system. So if you've got, let's say, a version of Windows Server that only supports on that particular operating system 4 logical CPUs, then there's no point in adding more logical CPUs than that because your operating system will ignore the additional CPUs. Any virtual machine running on the ESXi 6 host can have up to 128 virtual CPUs, although that sounds pretty extreme. I can't think of a use case for that. Your maximum memory size for a virtual machine will depend upon the host's physical memory and the virtual machine's compatibility setting. The maximum size for any given virtual machine, it can handle up to 4 terabytes of memory. So that's quite a bit of memory you can handle. You can also set these parameters when you create the virtual machine, and you can change them later. In fact, some of these can be hot added, although some will require virtual machine shutdown. One other little note about the memory, you can accept the default unlimited memory resources. This allows the ESXi host to set the limit on the memory resource usage to the maximum useful for the virtual machine, meaning that it will increase or decrease the amount of memory as needed.